Welcome to the WWC Advanced Group Design Standards Training module, focused on the Functional Form and Bandwidth Standard for Regression Discontinuity Design, or RDD, studies. You can access all the resources mentioned in this module through the WWC website, whatworks.ed.gov. This module describes the WWC's fourth RDD standard, referred to as the Functional Form and Bandwidth Standard, which outlines requirements for RDDs to document the appropriate specification and application of functional forms and bandwidths used in the design. This module introduces the concepts of functional form and bandwidth and then describes how the WWC assesses these issues in RDD studies. After completing this module, you will be able to define why the WWC is concerned about functional form and bandwidth specification in RDDs. You will be able to describe the WWC's functional form and bandwidth standard and will know how to apply that standard when conducting a WWC review of an RDD study. The WWC's fourth RDD standard focuses on the appropriateness of the functional form and bandwidth specifications used in an RDD study. The WWC is concerned about functional form and bandwidth specification because, unlike in randomized controlled trials, in an RDD, statistical modeling plays a critically important role in estimating intervention impacts. As described in previous modules in this training series, estimating credible intervention impacts from RDD studies requires some sort of regression adjustment for the forcing variable in the impact analyses. As discussed earlier in this training series, two modeling approaches that are commonly used to reduce misspecification bias in RDDs are local regression and global polynomial regression. Misspecification in these regressions can lead to bias in impact estimation. For example, if a linear functional form was specified for the impact analysis when in fact the true relationship was quadratic. Thus, two of the most critical aspects of statistical modeling in RDDs are the functional form specification of the outcome forcing variable relationship and the bandwidth, or the range of forcing variable values used to select the analytic sample. As shown in this table from the WWC Procedures and Standards Handbook, to completely satisfy the functional form and bandwidth standard, an RDD study finding must satisfy 5 criteria. The study finding must estimate a local average treatment effect using a model that controls for the forcing variable, use a local regression within a justified bandwidth, provide evidence that the findings are robust to varying bandwidth choices, include graphical analysis displaying the relationship between the outcome or forcing variable and an appropriately fitted curve, and not constrain the relationship between the forcing variable and the outcome to be the same on both sides of the cutoff. To partially satisfy the standard, an RDD study must report a local average treatment effect using a model that controls for the forcing variable. Additionally, the study must either use a local regression with a justified bandwidth or a best fit regression. The best fit approach may use either the full sample or a sample within a specified, potentially unjustified bandwidth. Regardless of whether the authors used a local regression with a justified bandwidth or a best fit regression to partially satisfy the RDD Standard 4, the authors must report a graphical analysis displaying the relationship between the outcome and forcing variable. Otherwise, an RDD study finding does not satisfy the functional form and bandwidth standard. We now will describe each of these 6 criteria in greater detail. Criterion A of the functional form and bandwidth standard, which we will hereafter refer to as RDD Criterion 4A, requires that the local average treatment effect for the outcome must be estimated using a statistical model that controls for the forcing variable. In an RDD, for both bias and variance considerations, it is never acceptable to estimate an intervention impact by simply comparing the mean outcomes for intervention and comparison group members without adjusting for the forcing variable, even if there is only a weak relationship between the outcome and forcing variables. Criterion B of the functional form and bandwidth standard, or RDD Criterion 4B, requires that the study use a local regression or a related non-parametric approach, where impacts are estimated within a justified bandwidth. The WWC defines a justified bandwidth as one that was selected using a systematic procedure that is described and supported in the peer-reviewed methodological literature. Some of the most frequently used procedures are bandwidth selection via cross-validation, the plug-in or Imbin's Kalyanaraman procedure, or the Kalanico, Cataneo, and Tatunik procedure, also known as the robust CCT. Other bandwidth selection procedures are justified if they are described and supported in the methodological literature. For example, a procedure would be considered justified if it were described in a peer-reviewed journal article that describes its procedure and demonstrates its effectiveness. In contrast, any bandwidth selection procedures without methodological support would be considered an unjustified bandwidth. For instance, if an applied journal article simply described the bandwidth selection procedure, but did not empirically demonstrate its effectiveness. For studies that do not use a local regression or related non-parametric approach with a justified bandwidth, Criterion C of this standard allows for less ideal approaches. These approaches estimate impacts using a best fit regression that uses either the full sample or a sample within a bandwidth that need not be justified. To satisfy RDD Criterion 4C, the functional form of the outcome forcing variable relationship must be shown to be a better fit to the data for at least 2 other functional forms. Any measure of goodness of fit from the methodological literature can be used for this purpose, such as the AKIC information criterion, or AIC, Bayesian information criterion, or BIC, or other fit statistics such as an adjusted R-squared. Criterion D of the functional form and bandwidth standard requires that findings be robust to varying functional form or bandwidth choices, depending on the type of analysis approach that is used in the design. The type of evidence that is allowed to satisfy this requirement depends on whether the authors presented a model using a justified bandwidth, a model using an unjustified bandwidth, or the full sample, or both kinds of models. RDD Criterion 4D is complicated, so you may wish to pause or rewind the video to ensure that you understand it. First, let us consider those scenarios where RDD criterion 4B is met. When the impacts in the RDD are estimated using local, linear, or quadratic regression, or a related non-parametric approach in which impacts are only estimated within a justified bandwidth. Again, this is generally the preferred analytic approach for an RDD because it better ensures an appropriate functional form specification of the outcome-forcing variable relationship. In this scenario, when RDD criterion 4B is met, a study can satisfy 4D in one of two ways. The first is if findings from robustness checks demonstrate that the sign and significance of impact estimates is the same for or one additional justified bandwidth beyond the one used in the primary analysis. Two impacts are considered to have the same significance if they are both statistically significant at the 5% significance level, or if neither of them is statistically significant at the 5% significance level. Two impacts are considered to have the same sign if they are both positive or both negative, or if one is positive and one is negative, but neither are statistically significant at the 5% significance level. For example, if the sign and significance of an impact are the same using a bandwidth selected by cross-validation and a bandwidth selected by the IK plugin procedure, then a study would satisfy RDD criterion 4D. If a study satisfies RDD criterion 4B, the other way that a study can satisfy 4D is if the sign and significance of impact estimates is the same for the original justified bandwidth and two additional bandwidths that are not justified. As we have discussed, some studies may not estimate intervention impacts within a justified bandwidth, but instead may use best fit regression modeling approaches, such as global polynomial regression approaches, or they may use some other local approach with an unjustified bandwidth. If a study finding fails to satisfy RDD criterion 4B, then it is not necessary to consider the robustness requirement. However, some studies might present both a local, non-parametric approach with a justified bandwidth alongside a best fit global polynomial regression. In those cases, three additional options are available. First, the study could satisfy 4D if the sign and significance of impact estimates are the same using a total of at least two different goodness of fit measures to select functional form. This will typically mean one additional goodness of fit criterion beyond the one used to select best fit regression. For example, this criterion would be satisfied if the impact corresponding to the functional form selected using the AIC goodness of fit measure is the same sign and significance of an impact corresponding to the functional form selected using R². The second way a study finding satisfying RDD criterion 4C can also satisfy 4D is if the sign and significance of impact estimates is the same for at least three different functional forms, including the best fit regression. The final way the studies meeting both criteria 4B and 4C could potentially meet RDD criterion 4D is if the authors show the same sign and significance for the impact estimated within a justified bandwidth and the impact estimated using the best fit regression. These typically will be the models used to meet criterion 4B and criterion 4C. In the case where a study attempts to demonstrate multiple forms of robustness, the study meets RDD criterion 4D so long as one form of the robustness check meets the WWC's requirements. For example, imagine the authors from a study that satisfied criterion 4B demonstrated that the effect was positive and significant for two estimates using a justified bandwidth, but an estimate from an unjustified bandwidth was negative and non-significant. The study would meet the requirements of option 1 for satisfying criterion 4B, even though it would not meet the requirements for option 2. In this case, the WWC would still consider this study robust to varying functional forms or bandwidths, given that it satisfied option 1 for meeting criterion 4D. Criterion E of the functional form and bandwidth standard requires that the study includes a graphical analysis displaying the outcome-forcing variable relationship. The graphical display should not be obviously inconsistent with the choice of the bandwidth and the functional form specification used for the impact analysis. This graphical analysis must include a scatter plot and a fitted curve, where the scatter plot can present raw data or data averaged or aggregated within bins or intervals. Again, the graphical display must not be obviously inconsistent with the choice of the bandwidth and functional form specification used for the impact analysis. If a study uses a particular functional form for the outcome-forcing variable relationship, then the study must show graphically that this functional form fits the scatter plot reasonably well. For instance, if a study uses a local linear regression for the impact analyses, then the scatter plot must show that the outcome-forcing variable relationship is indeed reasonably linear within the chosen bandwidth. It is important to clarify that authors need present only the data they used for their estimates. For example, when authors only used data within a local bandwidth for impact estimation, it would be acceptable for the graphical presentation to show only the data within the bandwidth and ignore the data outside the bandwidth. Here is an example graph that displays a scatter plot of raw data and the fitted regression lines used to estimate the intervention impact at the cutoff score of 50. This graphical analysis would satisfy RDD criterion 4E, the functional form specification used for the impact analysis is consistent with the outcome-forcing variable relationship shown here. In this example, the authors used a global linear regression estimated separately on either side of the cutoff, and the scatter plot suggests that this is indeed a consistent and reasonable choice of a functional form to these data. In contrast, here is a different graph that displays a scatter plot of raw data and fitted regression lines used to estimate the intervention impact at the cutoff score of 50. Again, a global linear regression model specification was implemented on either side of the cutoff. However, in this example, the scatter plot suggests that this linear model specification is inconsistent with the functional form implied in the scatter plot. The scatter plot clearly indicates that the outcome-forcing variable relationship is not linear and would be reflected better in a polynomial model specification. This graphical analysis would not satisfy RDD criterion 4E because the functional form specification used for the impact analysis is obviously inconsistent with the graphical display of the outcome-forcing variable relationship. Criterion F of the RDD standard 4, which we will call RDD standard 4F, requires that the relationship between the outcome and forcing variable must not be constrained to be the same on both sides of the cutoff. In other words, the model specification used for the impact analysis must allow the outcome-forcing variable relationship to vary on either side of the cutoff. RDD studies that already have failed any of the eligibility criteria required to completely satisfy Standard 4 do not need to meet criterion 4F. As an example, a regression model where Y is the outcome of interest, X is the forcing variable centered around the cutoff value, and T is a dummy variable indicator for treatment assignment. The inclusion of a multiplicative interaction term between X and T, shown as beta 3 on this slide, would appropriately allow the outcome forcing variable relationship to vary on either side of the cutoff. Conversely, a regression model omitting this interaction term that only included a main effect for the forcing variable beta 1 and a main effect for the treatment assignment dummy indicator beta 2 would not satisfy this criterion because such a model specification constrains the outcome forcing variable relationship to be the same on either side of the cutoff. The reason for this requirement is that the presence of an intervention is typically expected to change the relationship between the forcing variable and the outcome. So best practice is to allow the relationship between the forcing variable to be different for the intervention and comparison groups. Time for your first knowledge check in this module. Authors state that they calculated RDD impacts using local linear regression, using the STADA command robust. Impacts of the mentoring program were estimated using the following reduced form model. yi equals beta naught plus beta 1 times tx plus beta 2 times GPA plus beta 3 times the interaction between treatment and GPA plus beta px I naught plus epsilon I, where yi is the outcome of interest, tx is a dummy indicator for assignment or not to the mentoring intervention program, GPA is a centered value of the forcing variable grade point average, xi naught is a vector of covariates including pretest measures of the outcome, and epsilon I is the error term. Does this study finding satisfy RDD criterion 4A? In other words, does the impact estimation model control for the forcing variable? A, yes, or B, no. You may want to pause the video now to think about your answer. The correct answer is A. Based on the information provided, RDD criterion 4A is satisfied because the impact of the intervention on the outcome was estimated using a statistical model that also controlled for the forcing variable. This is evidenced by the inclusion of the GPA forcing variable in the model specification. Thus, this study finding would satisfy RDD criterion 4A. Knowledge check 2. Recall the model from the previous equation. yi equals beta naught plus beta 1 times tx plus beta 2 times GPA plus beta 3 times the interaction between treatment and GPA plus beta px I naught plus epsilon I, where yi is the outcome of interest, tx is a dummy indicator for assignment or not to the mentoring intervention program, GPA is a centered value of the forcing variable grade point average, xi naught is a vector of covariates including pretest measures of the outcome, and epsilon I is the error term. Does this study finding satisfy RDD standard 4F, unconstrained on both sides of cutoff? Your choices are A, yes, or B, no. You may want to pause the video now to think about your answer. A is the correct answer. Based on the information provided, RDD standard 4F is satisfied because the authors have included an interaction between the forcing variable and the treatment, allowing the relationship to vary on either side of the cutoff. Without the interaction term between the program participation indicator and the forcing variable, the study would not satisfy criterion F of the functional form and bandwidth standard. Knowledge check 3. Authors state that they calculated RDD impacts using nonparametric methods to obtain a local polynomial regression estimator proposed by Kalanico, Cataneo, and Tatunik, 2014, namely the robust CCT procedure. The authors provide a citation to peer-reviewed methodological literature focused on describing the procedure and its effectiveness. Does this study satisfy RDD criterion 4B? Namely, does the study finding use a local regression or related nonparametric approach with impacts estimated in a justified bandwidth? Your choices are A, yes, or B, no. You may want to pause the video now to think about your answer. The correct answer is A. Based on the information provided, RDD criterion 4B is satisfied because the authors used a nonparametric approach with impacts estimated using a justified bandwidth from the methodological literature. Thus, this study finding would satisfy criterion B of the functional form and bandwidth standard. Knowledge check 4. Authors state that they calculated RDD impacts using a global best fit quadratic regression model. The authors report Bayesian information criterion BIC fit statistics for the quadratic regression model as 2.8 and for a cubic regression model as 3.9, where a lower BIC value represents better model fit. No other fit statistics are reported. Does this study finding satisfy RDD criterion 4C, best fit estimation? Your choices are A, yes, or B, no. You may want to pause the video now to think about your answer. The correct answer is B. Based on the information provided, RDD criterion 4C is not satisfied. For studies that do not use local regression or related nonparametric approaches to estimate impacts within a justified bandwidth to satisfy RDD criterion 4C, the authors must demonstrate that the functional form specification or best fit regression model was a better fit to the data than at least two other functional forms. In this example, based on the information provided, the authors only demonstrated that the quadratic functional form was a better fit to the data than one other functional form, namely the cubic functional form. Thus, this study would not satisfy criterion C of the RDD standard 4 or the functional form and bandwidth standard. Knowledge check 5. A study estimates an RDD impact using a global best fit quadratic regression that was selected over a linear and cubic functional form using the key information criterion AIC fit statistic. The authors report that the impact estimate from the best fit quadratic regression was -1.32 with a p-value less than 0.031. The impact estimate from the cubic regression was -1.75 with a p-value less than 0.018, and the impact estimate from the linear regression was -2.83 with a p-value less than 0.049. Does this study finding satisfy RDD criterion 4D, robustness? Your choices are A, yes, or B, no. You may want to pause the video now to think about your answer. The correct answer is A. Based on the information provided, RDD criterion 4D is satisfied because the authors used a best fit global polynomial estimation strategy, and the authors demonstrate that the impact estimate has the same sign and statistical significance for the best fit functional form, as well as 2 additional functional forms. Thus, this study would satisfy criterion D of the functional form and bandwidth standard. Knowledge check 6. An RDD study presents the graph shown on the next slide. The authors reported that they used linear regression within a justified bandwidth of -1 to 1, and that they allowed the relationship between the outcome and forcing variable to differ on either side of the cutoff. Based on this graph, does this study finding satisfy RDD criterion 4E? Your choices are A, yes, or B, no. In this graph, the solid vertical line represents the cutoff, and the dashed line represents the functional form of the regression. Recall that the authors reported that they used linear regression within a justified bandwidth ranging from -1 to 1, and that they allowed the relationship between the outcome and forcing variable to differ on either side of the cutoff. So again, based on this graph, does this study finding satisfy RDD criterion 4E? You may want to pause the video now to think about your answer. The correct answer is A. Based on the graph provided, RDD criterion 4E is satisfied because the scatter plot of the outcome and forcing variable does not show an obvious inconsistency with the specified functional form within the bandwidth. Thus, this study does provide graphical analysis of an appropriate functional form specification. The data are noisy, so it may not be clear that the slope of the best fit line in this plot was the best functional form for the data. However, a study finding should fail RDD criterion 4E only if the data are obviously inconsistent with the functional form or bandwidth choice. The data here are not obviously inconsistent with this functional form, so the study would meet criterion E of the functional form and bandwidth standard.
Knowledge check 7 on RDD study finding satisfies the RDD standard for criteria A, C, E, and F, but the study does not satisfy criteria B and D. For the functional form and bandwidth standard for the RDD standard 4, does the study finding A, completely satisfy the standard, B, partially satisfy the standard, or C, not satisfy the standard? You may want to pause the video now to think about your answer.
B is the correct answer. The study finding partially satisfies the functional form and bandwidth because it satisfies criteria A, C, and E. To partially satisfy the standard, it is not necessary for the study finding to satisfy criteria D or F. Recall that RDDs can use individual or cluster level assignment of units to conditions. When reviewers assess RDD Standard 4 for cluster assignment RDDs, there are no unique considerations required for these cluster level assignment designs. Namely, reviewers will assess study findings against RDD Standard 4 using individual level or cluster level data depending on what type of data the researchers analyzed. Recall that some RDDs may report pooled impacts for some combinations of forcing variables, cutoffs, and samples. Remember that pooled impacts are defined as those based on data from each combination of forcing variable, cutoff, and sample that are standardized and grouped into a single data set for which a single impact is calculated. When reviewers assess RDD Standard 4 for RDDs reporting pooled impacts, there are no additional considerations needed. However, when RDDs report aggregate impacts, there are a few additional considerations needed when reviewers are assessing RDD Standard 4. Remember that aggregate impacts are defined as those that are calculated as weighted averages of impacts, calculated separately for every combination of forcing variable, cutoff, and sample. When assessing RDD standards 4A, 4B, 4C, 4E, and 4F for aggregate impact findings, the requirements for these criteria must be applied to every impact included in the aggregate. Any impacts excluded from the aggregate because they do not satisfy one of those criteria will be treated as attrition. The aggregate impact then will receive the lowest rating among all impacts. When assessing RDD criterion 4D for aggregate impact findings, this criterion can only be applied to the aggregate impact. Namely, it is not necessary for study authors to show robustness of every impact included in the aggregate, although doing so is also acceptable. This concludes our module on the WWC's fourth RDD standard, or the Functional Form and Bandwidth Standard. Let's review what we discussed in this module. We described the 6 criteria used to assess this standard. To completely satisfy the Functional Form and Bandwidth Standard, an RDD study finding must satisfy each of the criteria 4A, 4B, 4D, 4E, and 4F, which all help to establish that appropriate methods were used to specify the bandwidth and functional form specification. To partially satisfy the standard, a study finding must satisfy 4A and 4E, and also must satisfy either 4B or 4C. Otherwise, an RDD study would not satisfy the functional form and bandwidth standard. Recall that there are 5 total standards that determine a study finding's research rating. You are now familiar with 4 of the 5 standards. For a study finding to receive a rating of meets WWC standards without reservations, the study must completely satisfy the functional form and bandwidth standard. For a study finding to receive a rating of meets WWC standards with reservations, the study must partially satisfy the functional form and bandwidth standard. A study finding that fails to satisfy the functional form and bandwidth standard will receive a rating of does not meet WWC standards. The next module in the training series will focus on the WWC's 5th RDD standard, which focuses specifically on how to review evidence from fuzzy RDD studies.